Good morning, everybody. My name is Aria Chambers. I'll be your moderator for today's webinar. Two notices before we begin. First, if you're joining us via mobile device, please note that you'll have the option of viewing either a panelist or the presentation, and you may change your view by simply swiping left or right on your screen. Second, we encourage you to ask questions throughout the webinar and use your questions chat section to get those questions to us. At the end of the presentation, I will read out your questions for the panelists to answer. With us today, we have AJ Patel. He is our Business Development Manager and has over a decade of experience in the oil and gas industry, including time as a reliability engineer and maintenance and planning execution lead. I'm going to pass it over to AJ to get us started.
Thanks, Aria, for the introduction. Good morning, everybody. I hope everybody's doing well. We had an interesting 24 hours with some crazy storms, at least in my area, some power outages. So I hope everybody is doing well and is safe out there. And so today we're going to talk a little bit about process safety management with a focus on mechanical integrity. For those of you who are in the processing industry, so oil, gas, chemical processing, even food processing, as you know, there are rules around process safety management, and one of the areas of specific interest is mechanical integrity. And so whenever we talk about process safety, it's best to start looking back at history and ask yourselves, why are we here? What are the things that happened over time that forced industry to say, hey, we need to take a closer look at how we act and what we do and what our impact is to the communities around us. And so the most notable event and what is considered one of the worst industrial accidents in history is the 1984 Bhopal incident with Union Carbide, with methyl isocyanate, essentially cyanide, where there was a release of the chemical out of the pressure vessels itself, and 4,000 people died. And the reason why this is important to talk about is because 4,000 people did not work inside of that Union Carbide plant. Most of those people lived outside of the plant. They lived in a village that was downhill from the plant. And the gas that was released is heavier than air. It rolled down the side of the hill, and it captured this village at the bottom of the hill. And so you're talking about innocent women, children, and men who ultimately perished because of that. Long-term effects, they attribute over 250,000 deaths to that incident. Soon after, the Chemical Safety Board was created in the United States in 1990, so almost 6 years later. And from there, OSHA created the PSM standard in 1992, which put several points of safety in place when you take a look at and analyze the equipment within your operation. But even still, in 2005, one of the biggest industrial accidents in the United States, the BP Texas City incident, where during the startup of a portion of a refinery in Texas City, there was a level indicator that was actually faulty. This level indicator because it was faulty, it allowed for the overfilling of a pressure vessel. A safety valve went off. So, okay, we prevented a pressure buildup and a potential hazard because of that. But on the same unit was an idling truck, and when this vapor cloud is released from the safety valve came in contact with that truck, you had an explosion that led to the death of over a dozen people. And then even more recently in Philadelphia, almost a year ago from right now, the Philadelphia Energy Solutions plant experienced an explosion at their hydrofluoric acid plant. Now, in that case, nobody perished, and in many regards, PSM turned out in many ways as a success because of many of the mitigative stances that were taken, but ultimately it led to the closure of the plant. And so I want to talk a little bit more about the Philadelphia incident, but I really think the best way to do that is to actually show everybody the video that was released by the CSB, which actually talks a little bit about what exactly happened. So I'm going to go ahead and play that video, and then we're going to continue our conversation.
June 21st, 2019. The Philadelphia Energy Solutions Refinery in Philadelphia, Pennsylvania. At 4 a.m., flammable process fluid, containing mostly propane, along with a small concentration of highly toxic hydrofluoric acid, or HF, escaped from the refinery's HF alkylation unit. likely through a ruptured pipe elbow. The alkylation unit produced components of high-octane gasoline. The leaking process fluid formed a large ground-hugging vapor cloud that surrounded some sections of the unit. 2 minutes later, the cloud ignited, causing a massive fire. A control room operator quickly took steps to prevent the release of additional HF by rapidly draining the unit's hydrofluoric acid to a special vessel designed to hold the acid in the event of an incident. At 4:15, during the ongoing fire, an explosion erupted in the alkylation unit. 4 minutes later, a second explosion occurred. At 4:22, a process vessel in the unit containing flammable hydrocarbons violently ruptured, causing the largest explosion. A large 38,000-pound fragment of the vessel flew across the Schuylkill River and landed on the river's opposite bank. 2 other fragments, one weighing about 23,000 pounds and the other about 15,500 pounds, landed inside the refinery. The fire burned for over 24 hours until it was finally extinguished the following day at about 8:30 a.m. 5 workers sustained minor injuries during the incident and response. The CSB is unaware of anyone experiencing health impacts from the hydrofluoric acid release.
All right, so when we take a look at that video and we hear that 5 workers were injured, and that was really the extent of what happened in terms of personal effect, the initial reaction is, okay, well, nobody passed away. I think we're in a good spot. And the fact is that ultimately what PSM is meant to do is prevent the loss of life. That's the thing that we're all most concerned about. And we're really, when it comes to people coming to work, that's what we care about the most. But let's dive a little bit deeper in there, okay? When these 5 workers were running across the field away from the process units, they were actually on the radio with the control room operator, who happened to be about a mile away in a central control room. And at that time, what happened was they actually called in and said, dump the acid, and finally the hydrofluoric acid was dumped out of the unit. Had that not been done, there could have been many casualties in this incident. The fact of the matter is, it was the inherent PSM training. It was the huge emphasis on PSM training that I know from personal experience that refinery had, which actually helped with the saving of lives. And so in many instances, that actual conversation is a very good, positive conversation. But there's a bigger picture here about the incident there, and I want to dive into that a little bit more. So when we talk about PSM, there are hidden but real consequences when it doesn't go when there isn't a focus on the right part of it. And so when events happen, when incidents happen, what happens? You can have damaged equipment that goes out of service. You might see fines coming in from your local governments, and you're going to have loss of production. And some of these instances, you can actually get insurance policies to help cover that if the incident is large enough. But the fact of the matter is that there's real hidden costs that aren't insurable. So first and foremost, having an unsafe work environment for employees. If you have a reputation for being a plant where people go to work and they get hurt or they potentially lose their lives, people aren't going to want to work there. And most importantly, the people that do work there, if something happens to them, what happens to their families? The fact of the matter is they're there to provide for their families. The plant's going to continue to go on whether or not something happens to them. So the real focus has to be on, what can we do to keep our employees safe? How can we have a safe working environment? The community. In order to operate in the places that we need to operate these plants, the fact is we have to have an emphasis and focus on the communities that surround these plants, because there's an impact there. Yes, we bring wonderful economic growth in those areas, but we also bring a risk. And so when we bring that risk, we need to have the faith of the community that we're capable of operating these plants correctly. And finally, environmental damage. When something goes wrong in a processing facility, the release goes into the environment, it goes into the atmosphere. And it's something that people ultimately have to breathe. And the fact of the matter is it doesn't matter where you stand on the issues, we all want to breathe clean air. And so we have a responsibility to make sure that we're doing all we can to ensure that we keep our processes within the pipes that they're supposed to remain in, and they don't go out of them. Why? We want to maintain safe conditions for the employees. We want to make sure we're holding faith with our community, and we want to ensure that we have clean air and water for everybody to breathe and drink. And so what can we do? What is the intention of process safety management, PSM, and all of this? What are we trying to accomplish? Well, there's three main phases. There's a hazard, there's an event, and there's ultimately a consequence to that event. And so our objective in PSM is to add as many layers as possible. We want to add prevention layers, which is doing everything we can to prevent an actual event from happening, such as a lease, loss of primary containment, it's called. And also put everything in place for, hey, a release has happened, everything we can do to mitigate and tamp down the consequence itself. So instead of having an explosion that might lead to the loss of lives, how can we ensure that maybe we have something like move the asset out of the unit, let's put it in a tank somewhere so that we can secure that and ensure that we minimize or completely remove the loss of life. The focus of our presentation today, I want to make it very clear, is on the prevention side. And what we're trying to do here at Belzona is we want to be a partner with your facility in helping you prevent the event from happening. Let me say that again. We want to be a partner in helping you prevent the event from happening. And so our focus today is going to be on mechanical integrity. And we can help you reduce the risks that you're going to face on mechanical integrity by helping you with some of the layers of mechanical integrity. Let's talk about design. Every piece of equipment that goes into a refinery, that goes into a chemical plant, that goes into a food processing plant, any sort of process facility, there's going to be fundamental designs behind it. Why? Because you just don't build a plant and put whatever piping you want in there. You have to think about, what metallurgies may come in contact with certain processes. Is that safe? Is that healthy? Is it going to affect the end product? And so you have engineers on staff that their main goal is to look at the design. But things change, process conditions change. The type of feedstock you get might change. It might change what that process looks like. And so design is something that gets frozen in time, but constantly has to get taken a look at. Inspection. Inspectors are the eyes and ears of your facility. Without inspectors, we have no idea what the condition of the equipment is. We don't know how our pumps are doing and operating. We don't know how our pressure vessels are doing. We don't know how our piping is doing. So inspectors play a key role in understanding, hey, this is where we might potentially have problems. They also are the record keepers. They're the ones that are holding on to all the inspections that are taken over time. And finally, your maintenance organization, the folks that are asked, hey, we've got a problem. Go out there, take a look at it. Let's replace some equipment. Let's understand when we pull it out, what are the challenges that we see in that? They're the folks that are actually going to help us execute whatever plan we put in place. Here at Belzona Repair Technology, we want to work with all three phases. We want to work on the design side to help develop solutions. We want to work with the inspectors to help to really understand what's the breadth of the problem we're looking at. And we want to work with your maintenance team to get involved, to show them some of the strategies and techniques that we have to help fix the problems. We want to work with all three layers, and we want to be a partner. So I'm going to go more into detail with some of our preventative maintenance and repair solutions we have. And after that, we're going to have a short question and answer session. And so let's start right at the top. Let's start with new piping and vessels, where, we might have a piece of equipment that we're replacing, and we know from experience, because of our inspection teams, that we've seen corrosion in this equipment in the past. And we're saying to ourselves, hey, how can we extend the life of it? Well, in many instances, it might be, hey, let's look at a higher metallurgy. And oftentimes, looking at more expensive metallurgy, a higher grade metal, maybe that metal isn't available. It might not be readily available, and it might be very expensive. And it might throw the economics of continuing to run that part of the operation. But we need to do it. So what's another option? What's a really good option? Belzona epoxy lining systems. The fact is that we get involved at the very beginning on the design phase in many of these projects, where we actually help engineers understand that rather than looking at increasing, the cost of a project, we can come in at the front end and say, hey, let's take a look at a lining system. It might be a better solution, and you'll get it at a fraction of the cost of metaling up. We can do that for piping, and we can do that for vessels. Let's talk about already in process active equipment. We talk about piping, we talk about vessels. In this case, our inspection team has gone out. They're doing their annual inspections, and they find that there are some areas of these equipment that they're below their T minimum. That sends a flag. Hey, we've got a problem here. The engineer starts looking at it and they decide we've got to do something about this. Given our current corrosion rates, we might be in a position where we have a loss of primary containment. It could be unexpected. And so let's be preventative. Let's be proactive. Let's prevent the problem from happening. What are our options? Well, replacement in kind is always the preferred option. Put a brand new of whatever's in there and let it run again. But here's the problem. It might not be cost effective. You might be looking at a piece of equipment that is part of a critical part of an operation, and you might have to shut down part of that operation. And that's not always the safest strategy, because shutting down equipment and starting up major equipment is not the safest thing to always have to do. In fact, we want to minimize that as much time as we can. On top of that is timing. What if we can't get that equipment that we need to replace for 4, 5, 6, 7 months, and you need to replace it before then because your calculations say, hey, I've got a really corrosive process here. What can I do? Well, you've got a great option. That's the Belzona SuperWrap system, where we've combined fiberglass and carbon fiber along with epoxy systems that we can actually utilize to rebuild the strength of this equipment from the outside in. Now, here's the good news. This is ASME PCC2 compliant. In fact, in my experience, what I know is when I'm doing my management of change paperwork, an incredibly important part of that is to make sure that I have all the calculations available to justify the repairs that I made. We provide you that. We will provide you all of the necessary calculations that you need to make sure that when you put this composite repair system in place, you're in a position to be able to show, hey, this is what I've done to make this equipment, to extend the life of this equipment. I'm going to show you an example. This is an elbow that we had at one of our crude units that we helped, and we put a wrap system on there. When you take a closer look in this red box area here, if I can get my pointer, if you look at the red box area, you'll see that there is actually a little bit of metal that was still remaining when we actually found the corrosion. And so the inspectors came to us and said, hey, what can we do about this? We went ahead and put a wrap system on there, and several months later, we took more x-rays, and in the x-ray, you can actually see here, you can see some of the wrap, you can see it here, but if you look closely, you don't see any metal left. And this is something that we see a lot of. When we do our design calculations for the SuperWrap, we actually design it to the process design, not what we have to make up in metal. Why? Because that metal is not going to stop corroding from the inside. So we want to make sure that when the metal's gone, the remaining Belzona that's left is able to withstand the process that's in there from a temperature and a process perspective. I want to talk about small bore piping. This is the Achilles heel of pressure vessels. We have these big, massive process vessels. They have huge cross-sectional areas, big diameters, but off of every single one of them, in order to hook up your instrumentation and a lot of your corrosion probes, you're gonna have small bore piping, and that might be an inch, inch and a half piping. Well, when you have big cross-sectional area with a lot of tiny little cross-sections coming off of it, you tend to get a lot of turbulence. And in all of those areas, you're gonna see welds. So you're going to have welds, you're going to have turbulence, you're going to have crevices. These are the perfect environments for finding and seeing corrosion happen from the inside. And they're very, very difficult areas to access. So what can we do? We here at Belzona, we have some great solutions for you. We can help by using concentric piping to actually push a coating system on the inside of this small bore piping. We can also put a super wrap system inside using the same technique, and it'll fold out over your welds on the inside of the pressure vessel itself. Flange face corrosion, very similar to small bore piping, high turbulence area, you're gonna see accelerated corrosion. And so when we look at these areas right in here where you see my marker, I'm gonna put a red circle over it. The fact is you have process fluid that's gonna move through, you're gonna start seeing a cutting in right here on this metal here, you're gonna start seeing a cutting in, and it's gonna start taking the strength off of what you see, which is this spiral wound gasket here. This is pushing against both flange faces. Well, if you start removing the flange face there, you're going to weaken the seal there. And what's ultimately going to happen, you're going to see process fluid pass right by that gasket. It's not going to work anymore. And so here's a visual representation of that, where the process fluid started working its way. Here you have the gasket seating area. And look, we penetrated right by that. And we're going to start seeing some process fluid spray right outside the nozzle itself. And oftentimes, these flanges are sitting right on a process vessel, and it's not easy to just cut them out and replace them. So what can we do? Well, there's a few things that we can do. A, before we even put something like this in service and we know that there's a problem, we can go ahead and put a coating system on there that's going to be completely compliant with what ASME wants us to do in B31. And the fact is that we can go in there, we can put this coating system on there, and we can prevent the corrosion from happening. In the event that the corrosion has happened, which again, we want to be preventative, in this case, I'm going to talk mitigative only this once, we can actually rebuild that flange face in situ, meaning we can do it in place. We're not going to use hot work, and we're going to be able to get you back up and running fast. Corrosion under installation is another important area of consideration. This is like the hidden danger when we talk about places where you could potentially be exposed. And corrosion under installation will impact piping and pressure vessels. So how does it work? Ultimately, we have piping that is hot. And when you have piping between 150 at 150 degrees and above, you want to make sure you insulate it for two reasons. Number one, safety of the people that are going to be around that piping. You don't want anybody leaning over, touching that pipe, they get a burn. Oh my God, we got a recordable injury. That is absolutely something and everything we want to avoid every single day of the week. The second part of it is conserving energy. The fact of the matter is, when you have hot process fluid, you can recover the energy out of that at a later time, and you could save a tremendous amount of cost. So that's why we insulate piping. It's safety, but it's also energy conservation. So it's necessary to do. However, it comes with a big downside. And that is when you put the insulation on, there's generally an aluminum cladding that goes over top of it that has caulk that's used to seal all of its joints. Well, once you go through a couple hot cold cycles, that caulk breaks, water enters, and now you got water trapped inside of that insulation. It's got nowhere to go. Well, you can imagine that if you've got water coming in, touching a hot pipe, and it's constantly flashing off, and then it gets to the inside of that outer layer and essentially condenses down, it's going to happen over and over and over again. You're going to start eating away at the outside of that piping. And it ends up putting you in a position where you start peeling off that insulation, and you're going to start seeing you're peeling off metal at the same time because it's worked its way in there. The metal starts to flake, and that's how it happens. And unfortunately, you would have a process leak and not even know it's there. And the areas you want to look at are processes that are running between 150 and 300 degrees. That's where your biggest exposure for corrosion under insulation. And so what can we do to help you? We can utilize heat activated epoxies to essentially coat that piping and make sure that when you put the insulation back over it, the piping itself doesn't come in contact with the moisture, thus preventing any more corrosion under insulation issues. In the event that you have lost containment on the pipe, or you're in a position where you know that you're close to doing so, we can always super wrap the pipe itself, and then we can put a coating system on it. Cooling towers are always an interesting topic because every time you drive by a cooling tower, what do you see? You see these nice, clean, fancy pictures, and people have an assumption that, hey, this is what a cooling tower looks like on every day. What can possibly go wrong? Well, the fact of the matter is, if you ever drove by a cooling tower on a cool day, it looks more like this. You have to turn your headlights off because it's very foggy, and you have to drive really slow by them because you can't see past your windshield. And so this presents a tremendous amount of opportunity for corrosion to take place. Why? Because you're essentially putting your equipment in immersion service. So carbon steel plus oxygen plus water is a very bad combination. And the fact of the matter is, you want to take the opportunity to proactively coat some of that metal. Why? Because if a cooling tower goes out of service, there's a very good chance a large portion or all of your plant is going to go out of service. Cooling towers generally tie in to almost to a large portion of the plant, not just one single portion of the facility at one time. And so this is a huge Achilles heel that could potentially get you in trouble, and there's a huge LPO associated with it. Yes, it's just water. It springs a leak. What's the big deal? The big deal is that if you can't stop it, you might have to shut down your operations. And you couldn't do something about it. You put in an epoxy coating system, you eliminate the threat. What do you do about the flanges? Well, we have a solution for that as well. We actually have an epoxy system that you can apply over top of your flanges and over top of your hardware. And if you use something as simple as a utility knife, you can actually cut it back. Your flanges will look good as new when you look at them. And it'll be way better than allowing years and years of pitting and corrosion to take place, making them virtually, essentially, the hardware is no good. It'll be frozen in place, and eventually over time, those flanges are going to lose their seal. And that's going to be a bigger problem to manage down the road. Pump seal leaks. Pumps are a big deal. You don't always think about how your pumps are going to fare because you might have replaced a section of pipe in another part of the line, but it might have put enough strain on the line that now your pump is vibrating. It only has to be a little bit of a vibration. If you don't necessarily have good vibration analytics going on, such as a Marlin system, you might miss it. And the fact of the matter is, whether you've put in a new motor, you swapped out the pump, maybe the pump base is going bad, maybe the motor base is going bad, maybe you swapped out some piping, all of these variables can lead to little micro vibrations within the pump. Well, micro vibrations start eating slowly at your pump shaft as it rides the seal. When it starts eating away enough and it's flexed enough, guess what happens? The process fluid inside the pump is going to start sneaking its way outside the pump, and now you've got a big problem. Oftentimes with shafts, you might be in a position where you might not be able to repair it because you don't have a replacement shaft in-house. You might not have the ability to weld on it because of the process fluid that's going through it. So what can you do? Well, we have a great solution here at Belzona where we can actually in place mold what we call super metal right around that area of the shaft, and within 24 hours we can get you back up and running. So to recap, risk. Everything we're talking about is reducing the risk from the hazard and the potential event. And what do we want to do to reduce that risk? We want to add preventative layers. Here at Belzona Repair Technology, we want to be your partner. We want to be your partner in increasing the number of layers that we can put in place to help an event from actually happening. And finally, where should you be looking? You want to look at thin piping and vessels. Anywhere you know you've had issues in the past, you want to take a moment to look at those. Small bore piping and flange face corrosion. Again, all that tiny piping coming off of your massive pressure vessels. There's opportunities for corrosion to happen. There's opportunities for an LOPC event. You want to focus some attention there. CUIs and cooling towers. CUI and cooling towers. We want to make sure that the hidden danger of CUI doesn't harm your operation. And we want to make sure that your cooling towers are well taken care of. Finally, your pumps. Make sure you're taking a look at your pumps. Make sure that if there's a potential problem with one of your pumps, there's some vibrations, you hit it early before the problem actually happens. And so I want to thank you for taking the time to spend with us this afternoon. I'm going to introduce at this time Mark Borski. He's our technical manager. Mark has over a decade of experience when it comes to working with Belzona. In fact, my time as a reliability engineer, it was Mark that introduced me to Belzona and educated me so much about it. And so I'm going to bring him on in, and Aria as well, and we're going to go ahead and answer some of your questions.
All right, thank you, AJ, for a great presentation. To get us started, we noticed that tanks weren't mentioned. Are tanks considered a part of PSM?
Oh, I'll actually take that one. So that's actually a really, really great question. And, we covered a lot of topics and we didn't cover tanks. And the fact is, tanks are absolutely a huge part of PSM. And it's something that we actually did a presentation just last week on some of the strategies that can be utilized with Belzona on helping you with your tank PSM issues. So I'd encourage you to come to check out our website and www.banksindustrial.com. Come check out our website. We've actually got the webinar from last week, and you should be able to answer a lot of your questions there.
Thank you. Sorry for that mix-up there. Also, are there Belzona solutions for tanks?
Absolutely. As I just mentioned, the tank-based sealing is one of them. If you remove some of that insulation, that's exposure to CUI. If there's areas of the tank that are corroding, we can do some wrap systems there. We can do some patch systems there. So absolutely, we've got great solutions for tanks. And I'd encourage you at banksindustrial.com. We've got a webinar there. Check it out. It's really good.
Thank you. Another question we have here, can a Belzona liner be applied to stainless steel?
You want me to field that, AJ?
Yeah, go for it, Mark.
So Belzona liners are 100% solids epoxy coatings, and they adhere by mechanical adhesion. When you create a blast profile, an anchor profile. So the metallurgy isn't as important. So yes, you can apply the stainless steel, different alloys, cast iron, pretty much anything you can put a profile in. People look at carbon steel, and sometimes they have issues with that, and they'll change the metallurgy to a stainless steel or an alloy, and they won't realize that they've created another problem, possibly stress corrosion cracking or metal fatigue, and that has to be protected as well. Sometimes when you weld on alloys, you change the metallurgy just with the heat affected zone. So sometimes you have to protect those as well. When you make repairs to alloys with weld overlay, you might not be able to post weld heat treat that area. And once again, you can put a protective coating or protective lining on that in place of that.
Mark, could you also speak to the question? We mentioned that Belzona focuses on preventative, I'm sorry, I'm clicking on the wrong question. Do we have products that protect pump impellers from wear and abrasion?
Absolutely, absolutely. Belzona has been coated on impellers for 60 years. Impellers see a lot of cavitation damage. Belzona has coatings that help resist cavitation. For those of you that are familiar with cavitation, it's a very aggressive activity. And it beats hard things like steel and alloys. And you need something that has some sort of rebound. So we have some elastomeric coatings, and we have some coatings that have a little rebound to them, and they're able to absorb that cavitation damage. Impellers that see abrasion from moving slurries, so wastewater plant or pumping out of a deep well or a river, we can protect those with ceramic filled coatings that can take that abrasion.
Thank you. Another question we have here, what are the temperature limitations for Belzona?
I'll field that one as well. So there's two different temperatures that we really look at when we're dealing with an organic coating like Belzona, and that is what we call a dry temperature. So if you're using the material in a non-immersed environment, you're using it to bond something to a tank, for example, or you're using it externally, that temperature is the maximum temperature that organic coating can handle before it begins to break down chemically. And for pretty much across the board for all organic coatings for any epoxy, that's going to be about 450 to 500 degrees. At that point, it's going to react with oxygen, and it's going to degrade. The other important temperature that we need to worry about is immersion temperature. So just like a lot of items you have are dishwasher safe or not dishwasher safe, epoxies are a polymer, basically a plastic type material when they're polymer or when they're catalyzed. And some epoxies are able to handle higher temperatures than others based on how they're cross-linked. So for Belzona has some of the highest immersion temperature coatings that are available. Really, the maximum temperature you get to on the immersion side is about 350 degrees. Above that, you're not going to be able to use an organic coating. On the cold side, get down to about -40 is the cold side. So it's a pretty decent temperature range. The good thing about above 350 is that generally above those ranges, you don't have the same kind of corrosion in a vessel that you would have at the lower temperature. You've kind of exceeded the corrosion range.
Thank you. AJ, earlier in the presentation, you went through the PSM just stages, and we mentioned that Belzona focuses on preventative measures. Do we also have solutions that are mitigative once a problem occurs?
That's a great question. So frankly, yes, absolutely. So many of the examples that we actually showed within the presentation itself, those solutions can be utilized if an event happens. Our encouragement in this was, hey, let's be preventative and get to it before it happens, but it's fine. Let's talk a little bit about the mitigative side. The one that comes to mind the most, and probably where we spend the most mitigative time, is SuperWrap. So if you have a loss of primary containment, whether it be on a pressure vessel, a heat exchanger, which is a pressure vessel, or piping, the fact of the matter is we often get called in and say, hey, we've got this huge area. How do we go ahead and what do we do to prevent the leak or stop the leak, and how do we continue our operation? So we've utilized SuperWrap in many of those instances. A temporary stop point will be put in over wherever the leak is, and then a wrap will be designed and installed. Another area, actually, I showed it was the flanges. If you come across a leaking flange, you're able to isolate and shut down that portion of the plant. You're able to get at that flange. You might break the flange itself, and all of a sudden you find out you've got some heavy corrosion. As Mark mentioned before, oftentimes if you've got to do work like on something like that, like a well buildup, you might have to get a hot work permit. You know, it could be a stainless steel. Now you're talking about utilizing a heat treatment to heat the metal up and lower the heat down on that piece of equipment. You're talking about a huge pressure vessel attached to it. You can't just lop off the flange itself. We can actually do those types of repairs right in place. And so, yeah, we have great mitigative solutions. If you do have a problem, and we want you to call us then too. We would just like to see us stop them before they even happen. But absolutely, we're certainly a partner on the mitigative side. We want to be there. We want to help you, and we want to be a resource for that. So, Mark, if you've got anything to add, I'll let you.
I will. I mean, from a cost standpoint, from every standpoint, if you can identify an area that is potentially going to leak and do something about it before it leaks, it's just so much more effective. We've even, you know, we've super wrapped pipes and systems and tanks and vessels where we've identified, or the owners identified, that there's a thin wall and there's a potential for a leak down the road. Many times we've even wrapped as a preventative measure areas that we know are going to be problems in the future. You know, you have a bend in a pipe, or you have something where you get a leak in that same spot every time, and we've wrapped brand new equipment, either internally or externally, you know, just as a barrier for, you know, to make it last longer and to prevent that release that you know, that we're trying to avoid with PSM.
Thank you both. At this time, we are going to, we actually have one more question that just came in. What's the most common area where you've used super wrap as a preventative measure? I think you touched on it a little bit.
Let me jump in there, EJ.
Yeah, go for it.
Most common area. Process piping is the most common area as a preventative measure, because that's the highest risk area. You know, where if you have a release, that's where it's going to be. You know, service water as well. I mean, we've done some service water piping for some nuclear power plants, where that service water, you know, would cause a shutdown of those plants. And that was primarily for microbiological mic corrosion that was internal. So internal corrosion is where you really want to do the preventative stuff. External corrosion, you know, if you catch it in time, you know, you can put a coating on it and stop the corrosion at that point. But internal corrosion, it's just going to continue to eat that pipe or that vessel from the inside, and there's no way of stopping it without shutting down and replacing the equipment. So I hope that answers the question.
Thank you. I'd like to thank you both for being on this question and answer. Thank you, AJ, for a great presentation. Thank you to the audience for attending. We're going to wrap up at this time. You will receive an email from us with more literature on products that we mentioned in this presentation and other resources where you can learn more about how Belzona can help you in your mitigative solutions. Thank you again, and we're going to wrap it up now. Have a good day.
Thanks so much, Aria. Take care, everybody.